So we're looking at 5.5, the difference of two squares, part 1. So you want those guided notes out, and we're going to begin with the warm-ups at the top of the page. So this first warm-up gives us a chance to practice what we did yesterday with 5.4 and Pascal's triangle. We have a binomial to the third power, so we can use that third row of the triangle where we have the numbers 1, 3, 3, and 1. And we have addition, so we don't have to worry about alternating, we just make everything addition. And our first term is x, so we want that descending, so we start with x to the third, x squared, x to the first, and x to 0, and that works out. And then with our second term of 2, we are going to have that ascending, so that's going to be times 2 to the 0, 2 to the first, 2 squared, and 2 to the third. And then, of course, we want to multiply those. So this comes out to just x to the third because of anything to 0 power is 1. And then here we have 3 times x squared times 2 to the first. So that's going to give us 6x squared. Here, 3 times x to the first times 2 squared, which is 4. So that gives us 12x. And then anything to 0 power is 1, and 2 to the third is 8. So that's our simplified expression. So the next warm-up gives us an opportunity to practice that FOIL, first, outer, inner, last. So we'll start with that first term times first term, which gives us 4t squared. Outer terms, so we have 2t times the negative 6, which gives us a negative 12t. Our inner terms, so we have a positive 6t there. And then our last terms, and that's going to give us a negative 18. And simplifying our like terms, so we have 4t squared plus a negative 6t, and then we can write that as minus 18. So we'll move on to some vocabulary. To find the square of a number, you must multiply the number by itself. To find the square of an exponent, you need to double the exponent. The radicand is the number inside the radical sign. And the square root of a number, which means you're finding a number that when multiplied by itself, the product is the square of a number. So the square root of 81 would be equal to 9, because the number when multiplied by itself, 9 times itself, is that product inside, is that radicand of 81. Then moving on, if a squared equals b, then a is the square root of b. So we have the square root of x squared, square root of a variable, which just means that we're dividing the exponent by 2. So the square root of x squared, we would divide that exponent 2 by 2, which would give us 1. And so the square root of x squared is just x, or x to the first. 64x to the fourth is a perfect square. Because its root, 8, is a whole number, and the exponent of 4 is divisible by 2. So a perfect square has a whole number square root. And if you're dealing with the variables, then the exponent, being a perfect square, is divisible by 2. Therefore, for example 3, we're simplifying the square root of 64x to the 4th. We simply take the square root of 64, which is 8. There we go. And then we divide that exponent of 4 by 2. So that would be x squared. So taking the square root there and then dividing the exponent of 4 by 2. For the next example, thinking through the same process, so the square root of 121 would give us 11. We're taking the square root of x to the 6th by dividing the exponent by 2, which gives us x to the 3rd. And then that would be y squared. We're dividing the exponent by 2, and that would give us x to the 1st, or y to the 1st, or just y. So 11 x to the 3rd y. For the next part of solving a difference of 2 squares, we're looking at twin binomials with opposite sign. The difference of 2 squares. Got a wiggly picture there. Okay, so that means we've got binomials that look almost the same. We have the same term, first term, and you can see we have the same second term, but opposite signs. So we're looking at opposite signs, one being a plus and one being a minus. All right, so let's get those things out of the way. And then we can write that as a binomial. If we would expand it out and we would do our FOIL, then we would get, x squared plus, that's our, first term times first term, then outer, that would give us plus 3x. Our inner would give us minus 3x, and then the last term by last term would give us a negative 9. And so when we simplify these outer and inner terms, they cancel each other, and so we end up with x squared minus 9. And that's where we have that difference of 2 squares. Our difference is our subtraction, and then we have our 2 squares, so the difference of 2 squares. So we have our difference of 2 squares there. When we have that, the result is going to be 2 terms. Both terms are squares. And it's the difference of 2 terms always. So this one says your turn, but I'm going to lead you through it. Again, we have twin binomials. We have the same first term, opposite last terms, or the same last terms, but with different signs, opposite signs in there. And so when we would FOIL and simplify, we get our perfect square. And so that 3x times 3x, that gives us our 9x squared. And this is going to always end up in a difference of squares, so we know that's subtraction. And then the square of the 4s would be 16. So that, you're just kind of learning that pattern. Now again, you could always go back and do the FOIL process for that, and you would get, the first is going to give us our 9x squared. Outer is going to give us plus 12x. Our inner would give us negative 12x. And then our last is that negative 16. And what happens is that we see that these 2 terms will cancel. And that's going to happen every time with that difference of squares, which is why we can learn the pattern and just go right to that simplified answer. Okay, so now this one really is your turn. I want you to try it. So you should be pausing the video and giving yourself a chance to figure this out. Go on, pause the video. Okay, so you either pause the video. Okay, so hopefully you did some of that work on your own and you paused the video and did your turn. And let's look at what you should get. So we have our x to the third and x to the third, we have our opposite signs. We have our identical terms there. So we know this is a difference of squares. So we square our first terms, and x to the third times x to the third is x to the sixth. Remember, when we're multiplying, we add those exponents. Difference means we separate it with subtraction, and 9y times 9y gives us 81y squared. So hopefully that's what you got. Looking at the next example, again, we check. We've got a difference of squares here. Same first term, opposite signs, same second term. So we're going to put our first terms together there, and our 4x squared times 4x squared would give us 16x to the fourth. Separating, difference of squares, separating with subtraction, and then the 5y times 5y is 25y squared. Now, I don't want you to get used to just like multiplying the first and second terms. You have to remember that this works with the difference of squares because those same terms and those opposite signs allow those middle terms to cancel. This does not work with those, other binomials where it's not a difference of squares. If you only multiply the first and the last terms, you'll miss the middle term. So it just works with the difference of squares this way. Okay, so this example is not on your worksheet, but I just want to highlight the fact that those, just like multiplying those two terms, only works with the difference of squares. Here we have the same first term and the same last term, but we don't have opposite middle signs or opposite signs. So if we would FOIL this, we multiply everything by everything, this is going to give us x squared times x squared is x to the fourth. That's our first. Outer is that plus 4x squared. Inner plus 4x squared. And then last plus 16. Now when we don't have that opposite signs, these middle terms, they didn't cancel out. They're both positive. And so we get x to the fourth plus 8x squared plus 16. That is not a difference of squares because we don't have opposite pieces, opposite signs, and so that middle term needs to be there. Now, if we would have this next one where they are the difference of squares, we have those opposite signs in there, and we FOIL that out, we're going to get x to the fourth for first. Outer is the minus 4x squared. Inner plus 4x squared. And then last, the minus 16. And you can see that those middle terms, because they're opposite like terms, they cancel out. And so you end up with that x to the fourth minus 16. That's that difference of squares. So it really makes, you have to make a point of really looking at the two binomials that you're multiplying before you decide to follow that pattern. All right, guys, catch you Monday.